Hello, grade 9 learners! Welcome to Bamboo Telescuela. It is amazing to think that we are now on the last quarter of this school year. In spite of everything, we can able to learn and nurture our mind. I'm excited to begin with our fourth quarter with a smile. This is Ma'am Junabelle, your teacher in Mathematics 9. But before we start, get your module, grab a pen and paper, and go to the most comfortable place and tune in to DWDY AM and CMD Cable Channel 11. We are also streaming live at SDO Kawayan City Facebook page. Have you ever dreamed to go on the places like Paris to see the Eiffel Tower? Or you want to see the beauty of Mayon volcano? Or you want to go to Japan and see the Mount Fuji? Or do you want to climb the Mount Everest? It is really amazing that God created these things in this world. And it is amazing that some experts discover and study the heights of these tourist spots. That's why they are now belong on the Guinness Book of Record as the highest mountain, highest tower, and more. But don't you ever think that how they can able to know the distance or height of those things? Did you ever imagine that somehow you can also measure it? But how? You don't know the answer? Don't worry, because trigonometry will help you to discover it as we go through to our lesson this quarter. But today, I will going to introduce to you the basic things about trigonometry, which is the 6 trigonometric ratios. After going through this module, you are expected to determine the 6 trigonometric ratios, explain the following terms: adjacent, opposite, hypotenuse, and theta. Name the sides of a right-angled triangle in a relation to an identified angle. And lastly, identify the missing side of the right-angled triangle. Before we go on the 6 trigonometric ratios, we should know the definition and platform of trigonometry. Trigonometry is a branch of mathematics that studies relationship between side lengths and angles of triangles. It is only concentrated on 2 specific triangles, which are right triangles and oblique triangles, or the combination of acute and obtuse triangles. We can solve right triangles using SOHCAHTOA, while we can solve oblique triangle using law of sine and law of cosine. Now, let's proceed on the 6 trigonometric ratios. Let's start with the 3 basic functions, which are sine, cosine, and tangent, with the abbreviation of sin, cos, and tan. The other 3 functions are cosecant, secant, and cotangent, with the abbreviation of CSC, sec, and cot. Cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. Now, to get its ratios, it is taken from a right triangle. Let's name this triangle ABC, and let's name the side using the lowercase letters ABC. Since it is right triangle, the longest side called hypotenuse, it is always the opposite of a right angle. And now, let us use this angle. It is represented by a Greek letter named theta, which will serve as our reference angle. Since side B is the adjacent of the theta, we will call it as adjacent. And opposite to our theta is called the opposite side. So how are we going to get the ratios? It is very simple. Just memorize the acronym SOHCAHTOA, which means S stands for sine, O stands for opposite, H stands for hypotenuse. While on Ka, C stands for cosine, A is for adjacent, H is for hypotenuse. And lastly, on TOA, T stands for tangent, O stands for opposite, and H is for hypotenuse. So if we will write on ratio, sine theta is equal to opposite over hypotenuse. So on this given, our value of opposite is A and our value of hypotenuse is C. On our cosine, our ratio is cosine theta is equal to adjacent over hypotenuse, and tangent theta is equal to opposite over adjacent. A while back, I mentioned that secant, cosecant, and cotangent is the reciprocal of the first three ratios. Therefore, cosecant theta is equal to hypotenuse over opposite, secant theta is equal to hypotenuse over adjacent, and cotangent theta is equal to adjacent over opposite. Or we can have the acronym CHO, SHA, CAO. In order for you to understand more, take a look at the first example. Let us find the ratio given the right triangle with our angle base theta. First that we need to consider, where is the hypotenuse, opposite, and adjacent? In here, the hypotenuse is 10, the opposite is 8, and the adjacent is 6. So we can now find the ratios. In our sine theta is equal to 8 over 10. Since 8 and 10 is divisible by 2, we can simplify it by 4 over 5. Cosine theta is equal to 6 over 10 or 3 over 5. Tangent theta is equal to 8 over 6 or 4 over 3. On our cosecant theta, that is equal to 5 over 4. Our secant theta is equal to 5 over 3, and cotangent theta is equal to 3 over 4. On our second example, right triangle ABC with the given sides. First, we need to determine the opposite, adjacent, and hypotenuse. On this figure, we can see that the opposite is 4, the adjacent is 3, and the missing side is the hypotenuse. On this situation, to find the value of the missing side, we will use the Pythagorean theorem. Our formula here is c squared is equal to a squared plus b squared. C represents the hypotenuse, a and b represents the two legs. C squared is equal to 4 squared plus 3 squared. So c squared is equal to the square root of 16 plus 9. C squared is equal to the square root of 25. So therefore, our value of c is equal to 5. Therefore, the hypotenuse is 5. Since the side is already complete, we can now get the trigonometric ratio of the given figure. Sin theta is equal to 4 over 5. Cotangent theta is equal to 3 over 5. Tangent theta is equal to 4 over 3. Cosecant theta is equal to 5 over 4. Secant theta is equal to 5 over 3. And lastly, cotangent theta is equal to 3 over 4. I hope you understood our second example. But what are we going to do if the given side is a radical number? Let's take a look on the third example. Given the two sides on the figure, which is adjacent is equal to square root of 5 and hypotenuse is equal to 4. There is one missing side, which is the opposite side. In order for us to find it, let us again use the Pythagorean theorem on the formula a squared is equal to c squared minus b squared. A squared is equal to 4 squared minus 5 squared. A squared is equal to the square root of 16 minus 5. Since we can able to cancel the radical sign and the exponent since they are equal. So the answer is A is equal to the square root of 11. Therefore, our opposite side is square root of 11. We can now find the ratios. Sin theta is equal to square root of 11 over 4. Cosine theta is equal to square root of 5 over 4. Tangent theta is equal to square root of 11 over the square root of 5. On this situation, this answer is not acceptable in mathematics. So we must rationalize the denominator so that the radical will be removed. What we need to do is multiply the denominator on both the numerator and denominator. So the answer is 55 over square root of 25. Since 25 is a perfect square, the final answer is 55 over 5. Now, we can find the ratio of the last three trigonometric ratios. Cosecant theta is equal to 4 over the square root of 11. On this situation, again, since our denominator has a radical sign, we will multiply both numerator and denominator by the square root of 11. So the answer is 4 square root of 11 over 11, since the square root of 121 is 11. Secant theta is equal to 4 over the square root of 5. Just like the first one, we will multiply the square root of 5 to both numerator and denominator. So the answer is 4 square root of 5 over 5. Lastly, cotangent theta is equal to 5 over the square root of 11. And also, let us multiply both sides by the square root of 11. Therefore, the final answer is the square root of 55 over 11. Since 5 and 11 is both radical number, we can able to multiply them. Did you enjoy finding the ratios? I hope you do, so you can able to cope up on the next lesson. To refresh your mind on the topic discussed today, we must know that trigonometry is a branch of mathematics that studies relationships between side lengths and angles of triangles. It is only concentrated on the two specific triangles, which are right triangles and oblique triangles, or the combination of acute and obtuse triangles. We also discussed the 6 trigonometric ratios, which is the SOHCAHTOA, and their reciprocal, which is CHO-SHA-CAH. We discussed also the sides of the given right-angled triangle, which are the theta, or what we call the base angle, adjacent, which is the adjacent to theta, and opposite, which is the opposite sides of the theta. Hypotenuse is the longest side of a triangle and also the opposite side of the right triangle. We also discussed that if one side is missing on the given triangle, we need to find it by using Pythagorean theorem with the formula c squared is equal to a squared plus b squared. We can also apply rationalizing denominator if the denominator of the ratio is a radical number. To know how well you understood the lesson, try to answer this. Find the ratio of the given right-angled triangle. The answer is sin theta is equal to 12 over 13, cosine theta is equal to 5 over 13, tan theta is equal to 12 over 5, cosecant theta is equal to 13 over 12, secant theta is equal to 13 over 5, and lastly, cotangent theta is equal to 5 over 12. Let's go to number 2. Let's answer. Since we do not have the value of hypotenuse, let's find it first by using Pythagorean theorem. So the answer is square root of 2. So the ratio are sin 45 degree is equal to the square root of 2.
or the final answer is square root of 2 over 2 since you rationalize the denominator. Next, cosine 45 degree is equal to the square root of 2 over 2. Tan 45 degree is equal to 1 over 1 or 1. Cosecant 45 degree is equal to the square root of 2 over 1, or the final answer is equal to square root of 2. Secant 45 degree is equal to square root of 2 over 1, or the square root of 2. And lastly, cotangent 45 degree is equal to 1 over 1, or the final answer is 1.
Very good, learners. Thank you for your effort and participation. It has been a fruitful discussion with you guys. I hope that you understood the lesson in spite of this situation. If you have questions, don't hesitate to communicate with your teacher for more information and updates. Again, I'm Ma'am Junabelle saying that develop a passion for learning. If you do, you will never cease to grow. Have a good day and God bless us all.